Okay, so here we'll try to explain what is theorem 2.2, or this is also a converse of basic proportionality theorem. What this theorem states: if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So we will prove this theorem in contradiction method. What is contradiction method? It is like, first we assume something wrong and we will prove that what we assumed was wrong in the end. That is contradiction. So I will show you what is my assumption and I will prove that assumption is wrong at the end. So first, so this is the triangle ABC, and he tells that a line dividing the other two sides have the same ratio. So he tells the ratio is same, so AD over DB is equal to AE over EC. This is the statement what he tells. Line divides two sides of the triangle and we assume that DE is not parallel to BC. This is our assumption. We need to prove this as wrong. We'll see that at the end. So what we do, so if DE is not parallel, if DE is not parallel to BC, then we will draw another line DE dash, E dash, such that it is parallel to BC. If DE is not parallel to BC, then we will draw line DE dash such that it is parallel to BC. Get it? So we assume that this is not parallel. If this is not parallel, then we will have a parallel line DE dash such that it is parallel to BC. So if DE dash is parallel to BC, then according to our basic proportionality theorem, AD over DB is equal to AE dash over E dash C. If we tell that AE dash is parallel to BC, then according to our basic proportionality theorem, the line which is parallel to the base, the other two sides are divided in the same ratio. Therefore AD over DB is equal to AE dash over E dash C. So these two sides are equal. So we can take this as equation 1 with BPT is the reason. So if AD over DB is equal to E dash over E dash, also in the given statement we had AD over DB is equal to AE over EC. Therefore AE over EC is equal to AE dash over E dash C. How? Because this is already given. AD over DB is equal to AE over EC, and AD over DB is equal to AE dash over E dash C. So equating these two equations, we get AE over EC is equal to AE dash over E dash C. So this is equation 2. Now we will add 1 to both the sides. If you add 1 to both the sides, the equation will not change. What will it leads to AE over EC plus 1 is equal to AE dash over E dash C plus 1. We need to add 1 to both the sides. So if we evaluate this, what do we get? AE denominator is EC, AE plus EC is equal to E dash C in the denominator AE dash plus E dash C. So what is AE plus EC? AE plus EC, in the diagram, AE plus EC is AC. We write the same AC over EC. And AE dash plus E dash C. AE dash plus E dash C is again AC. This is again AC over E dash C. So if numerator is same, then denominator is also same. It cannot be different. Therefore EC is equal to E dash C, and hence E and E dash are same point. Therefore DE is parallel to BC. Therefore DE is parallel to BC, because we proved E and E dash is same, it cannot be different. So DE is parallel to BC, hence proved.